Hi guys, we're going to talk about algebraic expressions and like terms. We really need to talk about this in order to be able to add and subtract polynomials, which is where we're going to go next. So talking about an algebraic expression, right here we have the definition. So it's a mathematical expression that consists of variables, numbers, and operations. So an example of that would be something like this: 3x plus 4y plus 7. So that whole thing is an algebraic expression. Now that is made up of a bunch of terms. So let's go ahead and break that down. So terms are a number, a variable, or a product or quotient of numbers and variables, and that forms the entire thing. So you can see here, you got 3x, you got a number and a variable, and it's a product. Same thing with the 4y, and then this is just a constant term right here. So let's go ahead and get a little bit more descriptive within an algebraic expression, and we'll talk about variables. So a variable is a symbol, usually a letter, used to represent a quantity that can change. So going to our algebraic expression here, you can see that x, that's a variable, and y is a variable. Now let's talk about a coefficient. So when you go back to our term right here, the coefficient is a number that is multiplied by a variable. So for our purposes right here, that is going to be the 3 and the 4. Those two are the coefficients. And then the last thing we have here is a constant, which is a term in the algebraic expression that does not change. It's usually a number. So here, the 7 is the constant term. All right. So now what we're going to do is talk about like terms, because that's really what we need in order to combine any of the terms that we want to combine, especially when we're adding, subtracting, we need like terms. So a like term, or like terms, they are the terms in an algebraic expression that contain the same variable, which is raised to the same power. Again, same variable raised to the same power. So looking at A here, we have 4 and 7. Those are both numbers. They're both constants. So those are actually like terms. And then going to B, we have 5x and 8x. So they both have the variable x, and the exponent, even though it's not written, is 1. So they have the same variable raised to the same exponent. So these are also like terms. And then on C, we have 2x and 6y. So they both have variables, but unfortunately they are different variables. So these are not like terms. And then in part D, we have 8x and 3x squared. Now they both have the same variable x. The problem is with the exponent. See here and then here. The exponent for this is a 1, and then the exponent here is a 2. So while they have the same variable, they don't have the same exponent. So these are not like terms. And then the last one here, we have 5xy and 9xy. So they both have an x and a y, both have the variable, and the variables are raised to the same exponent, which is a 1. Even though it's not written here, there are 1s above those. So these are like terms. Now when you have multiple variables, understand that you have the commutative property multiplication. So if this was written as 9yx, they would still be like terms, because y times x is the same thing as x times y. All right, so we're going to stop here. And then the next video we're going to pick up with polynomial addition, because this is the whole point of why we did this, to set that up for polynomial addition.